I've always been fascinated by the mysterious nature of black holes. These cosmic enigmas are among the most captivating objects in our universe, defying our understanding of physics and bending the very fabric of space and time. Today, we're going to dive deep into the heart of these celestial monsters, exploring their birth, anatomy, and the mind-bending consequences of their existence. Let's talk about how black holes come into existence. Imagine a star, but not just any star. We're talking about a cosmic behemoth many times larger than our sun. As this stellar giant ages, it fuses elements in its core, creating heavier and heavier elements until it reaches iron. Now, iron fusion doesn't release energy. Without this energy to counteract gravity, the star's core collapses. This implosion happens at mind-boggling speeds, about a quarter the speed of light. The result? A supernova explosion that outshines entire galaxies. But what's left behind is even more intriguing. If the star is massive enough, it leaves behind a black hole, a region of space where gravity is so intense that nothing, not even light, can escape. Now, what happens when we look closer at a black hole? We encounter the event horizon, the point of no return. Cross this boundary, and you're trapped forever. Beyond the event horizon lies the singularity, a point where our current understanding of physics breaks down. It might be infinitely dense, concentrated at a single point with no surface or volume. Kind of mind-bending, right? So what would happen if you fell into a black hole? Well, it's not as simple as you might think. As you approach the event horizon, time itself starts to warp. From an outside observer's perspective, you'd appear to slow down, turn redder, and eventually freeze in time before disappearing. But from your point of view, the outside world would seem to speed up, as if you're watching a fast-forward movie of the universe. Now, depending on the size of the black hole, you might experience spaghettification, being stretched into a thin stream of plasma by the intense gravitational gradient. Or you might hit a firewall just inside the event horizon, instantly vaporizing. Either way, it's not a trip you'd want to take. And speaking of size, black holes come in a range of scales. You've got your stellar mass black holes, which are just a few times the diameter of an asteroid. Then there are the supermassive ones at the center of most galaxies, billions of times more massive than our sun. The largest known black hole, Ton 618, is a real monster, about 66 billion times the mass of our sun. Despite their seemingly eternal nature, even black holes have a lifespan. Through a process called Hawking radiation, they slowly evaporate over time. It's a weird quantum effect where virtual particles at the event horizon can sometimes escape, carrying away energy. The largest black holes could take up to a Google years to disappear. That's a 1 followed by 100 zeros. As we continue to study these cosmic giants, they keep challenging our understanding of the universe, inspiring us to push the boundaries of science even further.